So related to chemical and physical properties are chemical and physical changes. And what we need to think about in assessing these is what's happening to the atoms and the molecules in the matter when it changes. In a physical change, the matter will change its appearance, but not the composition. So as I was saying, when ice melts, it looks different. It's a liquid now. It'll run all over the place. But it's still water. The substance hasn't changed. In a chemical change, the matter does change composition. So copper turns green when it's exposed to the atmosphere. It reacts with gases in the air and moisture in the air to form new compounds. It's not pure copper anymore. Just like rusting would be a chemical change. This is the ability or the susceptibility of iron to rust is a chemical property. Actually doing the rusting is a chemical change. They're very closely tied together. So state changes are always physical change. The appearance may be significantly different, but the particles are unchanged. So physical change just results in a different form of the same substance. If I take a log of wood and cut it in half, I have changed its appearance, right? I've changed the mass because now I have two pieces that weigh less. But is it still composed of wood? Yeah. So cutting a log in half would be a physical change. If I put the wood in the fireplace and burn it, what do I have left at the end? Ashes. The substance has changed. That would be chemical change. So we've got fundamental changes in a chemical change. We get new substances. So when you're identifying whether it's a chemical or physical change, anytime you see a word like combustion or turns into or becomes, anything involving a change in what it is, that's going to be a chemical change. So a chemical change is a chemical reaction. A chemical reaction just describes what's happening. So the substances that were present before the chemical change are called the reactants, and the substances present after are called the products. And we write chemical equations that we'll talk about later. Very simply, we list the reactants and an arrow indicating the chemical change that points to the products. So the reactants react with each other to produce the products. We're not trying to be cryptic with all these terms we use. So let's look at an example. So here's an illustration of a butane lighter. So here you've got liquid butane inside the lighter, and if you flick this without igniting it, what happens is the butane will begin to escape in the gas form. So it's gone from a liquid to a gas, but the actual molecules are still the same. It's escaping from the lighter. It's a gas now, but the particles are the same. That's a physical change. If you flick this bic hard enough that you get a spark and you actually light the butane on fire, now you have a chemical change. The butane is burning and is being transformed through combination with oxygen from the air into carbon dioxide and water. And the particles have changed. That's a chemical change. We've destroyed the butane and we've created something new. So classify each change as physical or chemical. Copper metal forming a blue solution when it's dropped into colorless nitric acid. What do you think? Chemical. So here we have copper metal, and now it's changing color, and it's also not a solid anymore. There's a whole bunch of changes going on here. That's a chemical change. A train flattening a penny placed on a railroad track. That's going to be physical. It's still copper. It just is getting flattened. Physical change. Ice melting into liquid water. Physical. That's just a state change. How about a match igniting fireworks? That's chemical. The firework explodes, and what's left is very different, and you can't just put it back together either. You've destroyed it. Physical changes can be used to separate mixtures into their components. So one type of a separation based on a physical change is called distillation. And this is the process by which distilled spirits or hard alcohol is made. You've got your solution here that has the alcohol and other stuff in it, and you want to get just the alcohol out. If you boil this, the alcohol has a lower boiling point, so it will boil first before the water does, and it'll go into the gas state. Now, you don't want your alcohol escaping into the air, so you run it through this tube, and this is a condenser. It's a double-walled tube, and in the space between the two walls, you run cold water. So you cool the gas as it comes out, causing it to condense back into a liquid, and you collect it in this receiving flask. This can be used to separate any two liquids that have different boiling points. The one that boils more easily will boil off first, and you can collect it in this way. That's the distillation. So that separates based on differences in boiling points. Filtration is another way to separate a mixture. So here we're separating based on differences in state. Filtration works to separate a liquid from a solid. You do this at home when you make spaghetti or when you make coffee. You need to separate the spaghetti from the hot water. You use a colander. In the coffee maker, you use a coffee filter, which more closely resembles what's going on here. So you could think of this as the hot water with the coffee grounds in it, and you don't want those grounds in there. You want to get them out. So you run it through a piece of paper, and the water with the coffee and all of its yumminess can go through the filter, but the coffee grounds get trapped. And so you can separate a liquid and a solid in a mixture that way.